I guess it's like 4 of us here. So I can just like know each of, if I can just like know each of your names, that'd be nice. I'm Siddharth. Uh, Nice to meet you. I'm gonna be giving this like small little workshop, and because it's like a nice small crowd, we can just like keep talking, keep the conversation going. Whatever like you guys have in mind, I can like talk more about, dive more into. Um, my background has been like I've been building a bunch of agents ever since like you could do a function call with a model. And ever since that happened, I worked at a company called Composio where I like helped make these tools work really nicely for agents. After that, I've been like building a bunch of RL environments, which I'll explain later in the slides, that are essentially what agents you build, but like they're sort of like trainable agents. And yeah, I'll like sort of walk through how I have sort of gone and discovered agents, RL environments, evaluations, and like how like the training sort of happens. In the middle, I'll also talk a little bit about like a training run that I try to do on an RL environment that I made. I have a bunch of like documentation and training charts for it. The training run didn't go really well, but I think like it's nice. I learned a bunch of things, and I think as someone who's mostly been in agents and like trying to train agents, a lot of like nice things that you learn when you go and like try to do that thing happening. Can I know each of your names? Okay, nice to meet you. Okay, nice to meet you. Oh, nice, nice. Okay, nice. Okay, cool, sure, yeah. And like if you have built with agents or done any like training experience or like whatever like experience you have with LLMs, if you can like let me know, maybe that'll give me a nice points to maybe hint at. Like I like the structured data, I know something similar for you guys. Sure. Okay, cool, nice, nice. Okay. Okay, cool. Okay. Okay, cool, nice, nice. Cool. So I'm gonna be placed around here so that I can like move in between. I'm just gonna sit because like I don't need to, like I'll just stand and like walk through the things that I need to. Um, but cool. Yeah, so I want to give a couple of demos first. First is for like a live agent that I made, which can sort of go in and control an Android device, click on it, do tasks on it, and I have a bunch of tasks for it as well. I'm gonna run through one of them, and hopefully that runs right now and like it doesn't like explode in my face. How do I? So sorry for the dark mode, everything. It might be hard to read, but essentially, I have an agent that I made. I'm running it. I have a bunch of like tasks and whatnot. This task is, hey, just turn the Wi-Fi on, and so the agent gets a random Android system. The model is GPT 5.2. It's in debug mode so that we can like go and look at nice things. I'm gonna use this tool called SCRCPY, and what that does is it lets me view what the Android system is and what's happening on it currently, right? And I think the state has initialized and inference and rollout has started. I'll dive into like what all these terms are, but you can see like the agent has gone like I don't know if I can control this. I think that's a good idea. Yeah, so like it is currently like sort of on the settings page, taking a look at the Wi-Fi. It has a bunch of tools. It has like whenever you make an agent, you give it a bunch of tools which is hey, read file, write file, um, message this, do that. And right now here it has tools which is swipe, tap on whichever coordinates. The context it gets is the screen as well as like the annotated clickable elements from the accessibility tree of the Android device. So you can see like, I don't know if it is very visible, but there's a line here. So it has access to all of this and it knows the X and Y coordinates. So if when I do a click, the X and Y coordinates are like what the agent uses to click at a particular place, right? And here if you see, it says it's evaluating the task, turn Wi-Fi on, task evaluation complete, score is 1, right? So anyone who's sort of built agents will know that you want to test them out a bunch, you want to evaluate them and see how they run, right? Doesn't make sense to just like make an agent which has a bunch of tools in a loop and can do whatever and whenever and just give it to your users and deploy it to production. You probably want to evaluate it quite heavily. So when you evaluate it, you create a bunch of rubrics, which is hey, how does it work on test data 1, test data 2, test data 3. So this is one test data where it's like hey, just turn the Wi-Fi on. It's a very simple one. I didn't want to overcomplicate things. And like I got a score which is score of 1, right, which is cool. My agent runs, and I think you could also maybe see that the Wi-Fi is on here, right? So cool, yeah, this works, right? Just yeah. This is has image processing. It's a vision model, right? Yeah, it's a GPT 5.2. You can give it like an image, and it'll know what to do with it. So yeah, it does get. It sees the screen. Yes, it sees the screen. Yes. Along with that, it has like the metadata access to the accessibility checks and the yes. So there is a bunch of pre-processing, and again, like with agents, like right, the better tools you make for the agent, the better the agent usually runs, right? So here the information it gets, and again, this is an agent in like, if you've read about RL terms, this is the agent purely in terms of like the RL state, which is it is an agent which has access to an environment. Now, the better it can interact with the environment, the better it can change the state of the environment and then do its actions, right? So here the tools it has is like the tools and the environment state that it gets the image as well as the clickable elements from the accessibility, and all of these are like it doesn't get directly the image you see here. It'll get this along with like a text annotation over here saying that this is clickable, or a text annotation over here saying this is swipeable, right? So as because it gets this data, it knows what to do with it, and like it can start doing some tasks. So I have a rubric, right, and because I have access to the device state in this case, or I like if you look at it generally, I have access to the environment state. So I can look at the environment and say, was this change in the environment made? So I can actually look using ADB in this particular case and see was the Wi-Fi turned on after the rollout was done. After the agent said, I think at some point it would probably have made a tool call saying that status done, right? And once it does that, see, status completed. So once the agent said completed, because I have access to the state in code, I can just say, hey, was the necessary change in state made? And if it was made, I can give it a score of like okay 1, right? And similarly, I can give it like per step rewards, which I'll like talk a little bit later. The other, again, don't worry about the. I'll progressively disclose this. I just want to say that hey, if you built agents, this is one agent that you must have thought about. Your browser use, your computer use. There's another agent that I've built here. So I'm literally not going anywhere into like the training side of things. I'm just talking about agents. I'm just trying to hit and cover and like bring into idea the primitives of agents that we all have like played with, and then I like make the comparisons, right? So here I have this like, it's like really horrible. Let's see if I can like make it better. Give me a second. I don't think I can convert this into light mode, so I'm sorry, but I'll zoom in. Okay. So I have like a task given to an agent saying, hey, you missed several meetings recently and they have a bunch of pending meeting requests in the inbox. Can you just like read a bunch of unread emails and like reach out, reschedule, handle like Gmail and calendar and whatnot, right? And what it has access to is actually just a simple browser. And this browser has like Gmail and Google Calendar. Now this is not like exactly the Gmail and Google Calendar app. This is like a primitive, very certain app so that I can like give to the agent and have it play with it. But it has this primitive Gmail and primitive Google inbox. So as you can see, like all things that it has a bunch of like randomly generated information that I've just given it. We don't talk about like how I generate, but like say it's the task that I'm want to evaluate, which is how does this agent run using browser and like how to manage Google Calendar and my emails. So again, an agent that you all probably have thought about building. Now what I've done is that I've sort of made a directed basically graph, which is after each step I can control what happens where, and hence I can sort of like add an email to the state and like add in an email to the state and give it notification, because I'm just get what a real email inbox looks like. So after like 5 minutes of the agent, it'll get another email which has some information which I would want to process and work. It's a little bit complicated, but the main task is, hey, just handle my email and handle my data. Right? So if I run this, cool. I said, hey, like, make this for me. You have access to my Google and Gmail Calendar. If you look at each action, it has a bunch of tools. It has access to like the entire browser. So it'll look at the index or like it'll look at the browser and make and interact with this environment. Again, browser is the environment here. Agent is like the primitive agent, and it is making step changes to your environment, right? And something I want to show you is like for each observation, I'm sort of like setting like the entire like for each observation I'm sort of sending like what it is looking at, and I'm having the LLM like rationalize what it needs to do and like having it make a tool call. So here it's a tool call which I want to click on LLM, right? And if you keep it running for a long time, it will like click on say an email, click on the export, type the email, reply to it, reschedule the Google Calendar, and I can just keep it running, right? And this is again like agent that you thought about building, and would be nice if like these agents sort of like worked, right? So I'm just gonna stop like running this because this is a big task and a lot of evaluations to happen here. But again, very similar to this one, which is this is just an agent, and I have a bunch of evaluations here, which is how it performed on this task and the previous task, which is, hey, did it actually set my calendar events? Did it cause any like conflicts? It's like these are like all the parameters that you can think of when building an agent or like when testing or evaluating an agent, which is did it go well, did it do this call right, did it like task well, how granular can you break that down? That's like the best like evaluate agents generally, right? Now with this like chain of thought, so with the same state of mind, which like, hey, again, the second time, which is manage Gmail through a browser interface. What the point I want to drive home is that if you build an agent, you evaluate, if you build big enough evaluate and an agent, you have enough for what you probably want an RL environment for. And like actually, what these two things that I just built were actually trainable RL environments. Right? And when I say RL environments, I mean like an actual like environment on which if you add in a bunch of training algorithms and a training run and a GPU to host your local trainable model on, you can train an agent and have it like learn tasks. So say I do like one task individually and show you how I do a bunch of evaluations over each of these tasks. But say for the one, I have like 300, 2,000 tasks done by on recording audio, my file system on the device, or like whatever, right? And for the persistent one, I can just have a bunch of tasks, which is delete this email, add this email, add this person, keep it running, make sure everything runs. So I have to say, even if you have like 500 of such tasks, you have what you need in an RL environment, because all RL environment and probably built with like evaluations probably built, you probably can build with like tasks, right? So after agent, like your evaluation rubric is what an argument is. Right? So most of these that I've built actually go and like make an agent for the fun of it. I want to train models on it. So your agent is already running. If you like add what your relation is, and if you add like what your reward is, or if you on it, you can probably like you will like 40% there in training like a full like you probably 40% like a model for yourself. So this is something that's interesting to look at, which is the API design, like how like opening at or like if you're studying like old spiral engines, which is cat learns to walk slowly or active identity. The API design is mostly this is it interacts with the human, it does a step, it records the observation, gets the reward, and then gets the score, and if needed, it resets. So this API design is implemented in like most, if not actually mostly all the RL plus agentic training libraries that do. So Verify is one by this something called Meta. Meta has one, which is called HB search environment. Attendees is another, which is another library I worked on, right? And anything with like task and agent is going on, right? Now, what is this paradigm called, where like you can look at the environment and like understand what the reward is or like what the score is? It's called RL from Verify rewards. There are papers on it recently, and this is sort of what caused like the recent boom. Like why this is sort of like why everyone is sort of talking about post-training. This is why your Claude code works so magically well. This is why Claude Cowork works so magically well. This is why Cursor even launched its own CLI. Pioneer has its own CLI. Mostly why like you see so many like model companies racing to have a product that you can use and have it deployed amongst in like so many people's devices, right? And this sort of like happened post DeepSeek-R1, where like there's a reasoning boom that happened, and then post reasoning boom and like the proliferation of the GRPO algorithm, RBR, where you can just like verify what the model did very well came on. And this is why models are so magical like coding and math and like Olympiad level things, because you can in the end verify what code was written, you can in the end verify the math theorem that the model worked to prove, and verify all of it, right? And so anything that is verifiable is trainable. So your agent that worked on some tasks had some errors, which means it was verifiable in tasks, which means it became trainable, right? Any questions here till now? Happy to like dive back, give some more clarity on things. Like feel free to just like in between, or like just let me know like, hey, can you speed this up? I already know this. We're like 5 people here. It's like I don't think this should be really formal. The agent was running locally. It was talking to the Android device using ADD. No, ADD, like the agent is running locally here. The Android device is also running like a virtual machine. It's talking over ADD. Yeah. Yeah. So what number you give as a reward? Like, so the typical paradigm would be, if you've thought about the game of Pac-Man, let me just like pull up Pac-Man, right? Pac-Man, and I'll just see if there's an image here. So if you look at this Pac-Man, right? Like here, I'm just gonna do a little bit of sidestep, which is, hey, you want this little Pac-Man to eat the white bits. You want to avoid these, and you wanted to eat these because it's a power, right? So you can just scale things down as to what your tasks are. Let's say it ate this, you give it a 0.5 reward. Every time it ate like the big pellet, you gave it a +10 reward. Every time it like hit one of these and died, you give it a -20 reward, right? You can just scale up like what the rewards are. Usually it's just nicer to have it on a 0 to 1 scale, or maybe a 0 to 10 scale, because in the end, bigger numbers are a little bit hard to like understand, like scale down. Because in the big gradient updates in any ML model is never nice. That being said, you can have like any number of like the integer number of like what is not the biggest deal, because in the end, it like during the training run, whenever like whatever algorithm you use, it scales down, like, or it does a soft max. So like if the rewards are on the scale of 100, because like the rewards are either 100 or 50 or maybe 10, it will just be like, okay, cool, I can like like the algorithm does that for you. I hope that makes it clear. So those are things that are sorry. Yeah, RL is in those situations. If you sort of thought about or like read about like the RLHF phase of training a model, and I'll like actually step into it literally after this. Those things are what you call preference training, and RL is used there as well. And for these non-verifiable things, and like it's sort of like a shifting phase, but every model after it's trained, it goes through like an RL phase, which is like preference training, where it gets better at writing poetry, it gets better at generating coherent text, it gets better at like non-hallucinations. RL algorithms are used as well, but the training that happens for that is a little bit different. It's more of like what is the distribution of text the model should output rather than what is the chain of actions the model should take. So when you think about poetry, it's like what is the next prose, the next poetry, and when you think about this, like the model has learned a lot. Like after like you take like GPT-4, it's learned how to write text well, but after that, you want to take action. So like after that, it learns how actions are. You have to train it like what it actually. RL happens on like posting and RL happens on like a pre and training guidance. I'll sort of talk about them in a sec. So you like as for like the rewards, let's say you want to model how to count letters, people always used to ask how many letters in strawberry, and it was like so like it was a big deal for so long. But like now model is generally quite good, and also hey, if you want like a model that you're training to not be told on Twitter or LinkedIn by these like people like it doesn't know to count the number of R's in strawberry, you can just train it to like do that, right? So here it's like let's just say a random word, get a random letter, and so you just get a prompt which is how many A's are there in like random word, how many R's are there in strawberry. Right? Then you do a step through it. And you score meaning you take the response from the LLM and then you take it after passing and then if it's correct, you give it as 1 reward. If it's not, you give it a 0 reward. Right? And you can slowly scale it up to the number of words. You can maybe scale it up to the number of sentences. You can do like an entire sentence, how many is there, right? And so I asked a small RL training last night. I thought it'd be a small run, but then I ended up at 3 a.m. The fact the model loves to count up to like 5-letter words or whatever, but then as it scaled up the difficulty, because it didn't know how to reason about things, it just couldn't learn anymore, which is something I'll like explain a little bit later too. So it is like the thing that I was talking about. Also, like anything I can like explain or whatever to any questions, let me know. Yeah, so the thing is like, yeah, so the models don't really look at information using don't really look at information using like the alphabets. They look at things in terms of tokens, right? So then if you take any like, I think just Google this. Cool, yeah. So this is like the OpenAI, right? So if I just say hi, my name is Hasgeek. If you get this is like the model. What the model sees is not HI space MY space. Model looks at hi space my space name space is space Sid dot. So these are all tokens. Like the model doesn't really like look at what the bits. Model doesn't look on the same level of bits of information that like we do. Hence, like when you output something such as strawberry, like it doesn't look at things in the same way. It's look it sees 3 tokens. Like it doesn't really see R's or A's or B's here, right? So again, another interesting thing which I'll like loop back in during my training run, because I didn't really like teach the model to reason, and because the model just thinks in terms of, or like model's information bit is just tokens, it didn't really like know how to learn about these things, right? But yeah, anything else, or should I proceed?
Yeah. What model were you training for this?
I tried on Qwen 3 0.5b, then I tried on 3 4, and then I tried on Qwen 2.5 3b. So I tried three runs on 3 models as I also fixed my trainer code, because I was sort of like, I was just like stress testing and being like, okay, whenever something failed, I would like fix it and start the training run again. And like as I sort of came across different problems in different models, I tried these 3 models. But to get back to the also, if people are on the workshop and if they have any questions, let me know. Yeah, is anyone on the live stream? Okay, cool. Feel free to drop a question in the live stream. I'll be happy to address it. Yes. So this in particular, what I was trying here was like an R run where I was updating the entire like weights of the model, but you can also do something which is called a LoRa, which is a low rank training, where what you do is you don't update the entire weights because that's really expensive and that's going to take a long time. And what happens is that there is a thing called catastrophic unlearning that happens because like the weight sort of holds this arcane information for how to think about the world, or like just like coding, math, prose, poetry, whatever. If you start changing those, the model sort of like loses some skills that you may not know. So like what people now do is LoRa, which is what you do is just like a small MLP, and on top of which all the gradients of like the actual model pass through, they get readjusted for that particular task that you've trained a LoRa for. Where this thing? Yeah. This is like, I just use server. No, I edited a GPU. So yeah, cool. Should I proceed? Good. So, slowly unraveling a model of product like Cloud Code. Like people stopped using Cursor because Cloud Code was so good. Like, people are moving towards OpenAI mostly because Codex is so good, because they think Codex is so good. So you're slowly seeing that like, these model companies are sort of creating products out of their models. And this is something that's going to be happening. This is something that will keep happening also, because as you make a harness, and so like how everyone thinks in these terms like harness is where and how your model interacts with different things, right? A harness is sort of like also a little bit of a mode, because how well you can train, how well you can make a harness, how people use it, gives you a lot of feedback as how the harness can be. Also gives you feedback as to what are the places where the model is not performing correctly, and you can just train the model on the same harness. So if your model say on a bunch of tools which allows you to get files, edit files, use a batch tool, use a batch tool, using it or whatever, and you keep training on it, and then you have a bunch of people use it, and then you have a bunch of eval also. You can have what Cloud team has, and so you iterate much faster, and you end up knowing what to train on and what to tune on, and like how to mostly like fix your tools and like fix what capabilities the models are at. So this is something that's going to be that's going to keep, and that's why agency right end up becoming agency right. Cloud Code was written just to help you write code, but now internally Anthropic uses Cloud Code also to train Cloud. So we sort of in the thing which is the second half of AI, and I'm referencing these two blogs which have been like quite nice to read. I think will represent the next boom of like the training on which is model the product in the second half of AI. Like so, pre-training was like taking up 50% of like the compute budgets, and usually has right because you're literally like random zero weights, right? You teach them how to predict the next token, how to text, how to follow instructions. Then there's this thing called training. 50% of the compute budget has usually where you teach more like instruction-based tuning. You teach how to do chatbot. You teach it like how to maybe like behave in an OpenAI chatbot scenario, or like how to respond, how to say you're absolutely right. So 50% of the compute budget is usually there, and then post training is where like ILVR and like some form of RL2 is where compute budget is usually going. And with the 5%, like, I think is going, but like still like very sizably low budget of compute. In post training, it has led to like, very like big return for this investment, which increasing 5% of compute on pre-training is not going to get more. Like OpenAI has not done a big pre-train for 3.5, but it's done in a continuous train. It has not initialized model to scratch with pre-train like the like access. Feels really expensive when you do it. We run data. Everyone has the same data now. So now it's like in how well you represent data and how well you make the model seek and how well you make the model talk and how well you make the model. I will have to train it on how well you give it the capabilities are written. So what happens if you're investing more into this? This is 10%, 15%. This is very rare. Within the second half, where compute budgets on LinkedIn between are sort of diminished, and now people are now realizing this is going to happen. Right? So training plan has all look like this. Is pre-training, SE, or just is how just click that board. I say hi, you say back. When I say can help me, absolutely. Then the second which is okay. Don't talk about clicking drugs. Don't talk about like, harmful information. And then now we're in the RLVR saying like, cool, you are a model. Can you now actions against things in the world, right? So. Then like it is like mostly it is recommended to follow this pipeline, but the past has been like DeepSeek-R1 actually went and said, you know what, we're gonna recipe and present second, we'll just like go all in on and like you're gonna use this artist like this model. GRPO is like the model how to talk and say how to be a good chatbot, how to call stuff, right? But it's difficult to recommend would especially not recommend doing like this experiments with a couple of GPUs. You probably want to model first like doing RLV experiments, right? Cool. Before I proceed, any questions, any steps? Yeah, so I mean, harness is basically what you put the model in. Like let's say it's like this little model, you put inside this harness and then suddenly it has arms and like to control the environment. So that can be one. Yes, Cloud Code is a harness, Cursor is a harness. If you don't give these coding related agent tools, just if you don't give it tools, we use like give it the ability to only write poems and like respond to poems. That can be kind of harness, So harness is essentially what you wrap around the model, Yeah, all of those give it like rounded or become harness. The code. Yeah, the important thing is that this agent doesn't have to be an agent, but it's like most harnesses are like harness. So the Android thing saw that was a harness. The browser used Gmail and using that was a harness. Right? Like the only thing stopping the model from it's really like I think the distinguishing I have in my brain is that an agent usually stops pretty easy. Or like you want the agent to run for maybe a few steps. Harness designed well should let the agent run forever. Given a large enough problem, at least. But like you can like, if you don't design a harness well, the agent or like the model can just okay, I'm gonna open this file. The file is 3,000 lines long, and then its context has filled up and it has died. So a harness makes sure that it doesn't do that. Like you wanna make sure like these foot guns take these foot guns out of ways that the product or the model runs well or the training runs well. Because even maintaining, like you don't probably buffer the model to open a like a 500,000 character file because it's not going to be able to read anything. So maybe you design up those things. That's right. Anything else? I'm just going to get some water. I mean, like a language model. Like I think we're all like we're blurred. The difference between an SN and LLM is all very small now. Like a 32 billion parameter model that you can run on your MacBook Air, even a MacBook Pro, can do most of the things that like you could argue that an SLM cannot do a year ago. So like SLM now are like maybe 100 or 200, maybe less than a billion parameter models, and then at that level, it's very much like an algorithm plus training plus inference infra problem, and it is a agentic training. People are still trying to see, can you even like do inference on these like small models, small GPUs, and conveniently well without limiting the intelligence. Right? So I would say that like doesn't really matter in like 2026. I'm just gonna take a break for next one. That's okay. Hi, can I have some water? Water. Can I pause this? Pause the mic. Okay, cool. Like the audio is not going. Okay. Just check maybe if like the audio is. Okay, cool. Okay. So there is a prerequisite to like having or like doing RL training, which is the probability that your model can solve a particular problem has to be more than zero. You know, No, so SFT traces is like actually a full trace. So, if you built an agent, you see the trace, which is the model gets the system prompt and the user prompt. Then it thinks, does a tool call, thinks, does some action, says I'm done, right? And like if the model is too small or like doesn't know how to do it well, it can't do the full problem at all. So what you want is you take a bigger model on the same set of problems, and you collect these correct working traces. And this is what your SFT trace is. This is your agent SFT trace. Then you like do SFT training on your smaller model with this trace, and like when you do the SFT, obviously like you mask out and you focus on what the assistant tokens are, which is what the actual model is supposed to be saying. And then you say collect a bunch of samples and you do 20, 40, 70 steps for this. Then the model gets warmed up and then it becomes familiar with the problem space. The probability of it solving the model, because it has just seen it and it has been trained on it a little bit, the probability of it like doing it works.
Distillation process,
This is not exactly distillation. I've not like worked in and around distillation. Distillation works directly on like the weights. This is just SFT, and so it's a little like I haven't looked into distillation, so I would not be the best person to answer.
Anthropic is a news saying, some
Yeah.
accounts, fake accounts and
Yeah, so that is not for like this purpose, because there what they might try to target, and I'm actually just guessing, is that they'll take a bunch of random text and then see like what the log probs of like the tokens that the model says are, and then try to like distill that into their smaller models. And so it's not,
this is SFT is like
it's a warm-up phase. Yeah. This is essentially like whenever you do an RL training run, you need to do SFT. This is sort of like a step in your RL training where you do SFT so that it learns how to think about or do these things. So letter counting environment, right? I wanted Qwen to have some think tokens, do some reasoning in them, and then give me an answer between answer tokens, and then give me an answer in a specific JSON format. Now Qwen, I think the 3B and the 0.5B one, because it was just like not a very like not the smartest model, it didn't really even like give the answer in the correct format, right? So then I had to like do a bunch of SFT runs so that the model warms up a little bit, and when I say warm up, it understands what at least the answer format should look like and how it should do some reasoning, right? Because I took a bigger model and I had some SFT data and I showed the model that, hey, this is how you should give your answer, right? Once I did the SFT, then like the model became much more coherent at giving me the answer in the correct format, where think token, answer token, JSON format, right? And then like, because the P of good is, P of correctness is more than 0, training was happening. It learned a little bit there, It's sort of like curriculum based learning, like you want to make sure like your child can at least comprehend letters before you move on to words, and like how you do that is sort of a little bit similar to how you train these models. Yeah.
here the difference between SFT and distillation is the process here is SFT, but the source of that SFT data can be even manually annotated.
Yes.
The way that he is doing it is essentially like distillation from a bigger model, but distillation I think they
So-
use it for other purposes as well, but
Yeah.
the source of data is essentially
Yeah. And like in this example, because like letter counting is just so programmatically generable, like I didn't really even need a bigger model to generate these traces, right? I could just have a program, I could just like have a loop in code where like it just gives me a formatted output, and I can just like either say give me 100 elements in a list or 1,000 elements in a list, because in the end letter, I know what a letter is, I can programmatically have it. Like it is in the code, I can show it to you. But essentially, this is very programmatic, so I didn't really need a model to do it. You probably want a model's agent trace when it's say trying to solve a bug in the Django code base, You probably want like Opus's SFT trace. You probably want like Opus's trace for how it tried to solve a bunch of like difficult coding problems to warm up your smaller models as to how it should do some tool calls, how it should reason, how it should use the task tool or whatever, right? So,
And when you say 50, 60 steps of warm-up,
Hmm.
what do you mean? So, like the entire SFT data you run through 50, 60 times, is it? Or what do you mean by steps in that context?
So yeah, like so I would just have like say like 60 rollouts, right? And then they could be multi-turn, they could be single turn. Those were configurable, but I could just have like say correct answer, correct answer, correct answer. So problem, correct answer, format, problem, correct answer, format. And if you just like train on like 60 of those, that is like 60 steps, and then it was warmed up enough to continue on it. But like yeah, it is a high. This is like hyperparameter things. So I am still learning here. I think 200 steps also makes sense for like big more difficult things. In my case, I also again I like walk through my war journey for training this. In the middle, I discovered that there was a bug in my RL environment itself, which gave me like wrong reward signals, which made me do some wrong things also. So just something to keep in mind too. I'll walk through it. I'll get back to you on that.
So it's essentially SFT on like 200 samples run once.
Yeah. So RL is kind of like very efficient in context learning, and what I would like use to drive this point home would be if you say like give a model, if you say ask your model to say, hey, can you just like write code to multiply two matrices in and like format your answer in these Python based markdown backticks, right? Now if the model is like really dumb, and like nowadays models don't really do that, but like let's just say they are, the first time your model outputs, it will be like the format might be wrong, but the code might be correct. The second time the format might be correct, but the code might just be garbage. The third time the format might be correct, the code might be mostly correct with like, and there might be a bug there, right? So what you can essentially like sort of do is you take these three examples, you tell the model, hey, plus 10 for this because you did this correctly, minus 20 for this because you did this correctly. Like literally just tell the model this. Like talk to Haiku or like old models and be like, okay, you did this correctly, you did this correctly, you did this correctly. Now, I'm going to ask you a similar question, and then you'll automatically like see that, oh, it performs better, because in context learning is a thing. If you tell it how to like do something and you tell it like where it fucked up or where it like sort of like made a mistake, it will like learn from it and then continue. Now in context learning is just like in context learning, like the context length cannot like is usually not bigger than 100, 2000, 200, maybe a million tokens, right? So like why you do RL is that just so that it gets baked into the model weights, and then doesn't really like you don't need to, yeah, it's just more efficient, right? So there is like, given like the current race, given like the current paradigm of like saying that, hey, verifiable, if you have anything that's verifiable, you have an RL environment on top of it which you can train on. There is actually like a current like race to create and capture this verifiable data. There's a bunch of like links here, you guys can like go through it. I'll have like the slides and the GitHub repo posted. But if you've heard of the companies like Scale, Mercor, Surge, there's a bunch of newer companies as well that are like on this link over here. Or even if you've like heard of these like newer benchmarks where they teach they put a model in a vending machine and then ask it to make money. These are all benchmarks that are verifiable, because you can sort of scale up and verify that, hey, is the model making money? No, cool. Give it negative rewards. I'm breaking it. I'm being overly simplistic, but kind of you can do it, right? So there is like a new data boom for like going and capturing human work essentially, which is what parts of human labor is verifiable, all the model labs want to go and capture that. So if you've read the news, OpenAI is actually partnering up with like JP Morgan Chase's financial employees to go in and see how their work is done. There's a bunch of like there was a data annotation boom that was happening where like all the models were investing in these like data annotation companies, collecting preference information. There's like a similar but quieter boom happening for like verifiable information, and it's much more difficult too. You can't just like pay people $8 to $20 an hour and then just like have them annotate data. Like here, the verifiable information is directly dependent on like the human labor aspect of it and how difficult it is, right? So there's a reason why OpenAI at some point paid like PhD students $1,000 a day for like their traces essentially. So GRPO is like the, I think before we go into this, I might want to talk. Cool. So, where did this go? Cool. Yeah. So GRPO is like the core algorithm that sort of like unlocked reasoning at some point early on during like the reasoning boom of like models, and has been behind like RLVR, and then essentially like the RL training of an agent part of like the RL phase. And the good thing about GRPO is that it's really light and efficient. All you kind of need is just a bunch of rollouts. When I say a rollout is you give a task, instead of having a model solve it once, you have it solve it 8 times in parallel, or you have it solve it at 30 times in parallel, right? And given a task and a rollouts, given like a bunch of rollouts, you can just like use the rewards from each of those rollouts and like efficiently like teach a model how to perform better on that task essentially. I have like sort of vibe coded plus like trained and like implemented this in like this library called PicoRL. I think it's so, I'm gonna show it to you guys over here. Oh, nice. So this is like a library that I had been working on, where I was like, okay, cool. Let me like talk to Claude, learn like how these algorithms work, have it like help me write a trainer, have it help me train a model on it as well. So all the algorithms along with the important parts of the algorithms, because there's like a bunch of I mean, essentially, like with any difficult infra work, there is like the actual, maybe 200-line function or 200-line like file that actually does the work, and then there's like thousands of lines of code that just help make it run. So here it mostly focuses on the algorithm side of things, where it's like, okay, these are the things or the unlocks in the algorithm, and why it makes sense, and so it's sort of like broken down in that way. I also have like a full training loop along with the environment-based API that I was talking about earlier, where it's like, okay, the environment API looks like this. This is the step. This is the score. This is the initialization function and whatnot. And the train sort of wires it together, talks to the GPU, writes the torch code, writes the VLLM, starts the VLLM, does inference, change the model weights and whatnot. So that's like the glue that just makes everything work. And then like here is like my war journal, where like I sort of talk about the training run. So I can sort of like, I'm just gonna dive in and out of these things here because it's like very, I think like it's a little messy, but it's in the it's messy in the way that like it's how I learned things. So I will just show you how I learned about things, right? Cool. So yeah, so the trick for GRPO is that like you sample like a bunch of completions per prompt, and then like your advantage here is like, okay, what is the trainable score here is like your reward minus the group mean, and like your group mean is like for that group of like say 8 or 32, what is the average reward that each of those rollouts got, right? And here is like if you sort of like step through it, this is the core part of like the this is like the core part of the algorithm here. I think it might be nicer to, oh yeah, here it's nice, cool. So let's say like your rollouts, you're trying to train the model as to like, okay, can you just reason for me, just like teach the model how to reason, which means think token, some valid text, and then think token end, and then the answer, right? So your rollout looks like this. Think I need to do this, blah 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 blah, right? And the idea for like regular reinforce, so there's like 3 algorithms: reinforce, PPO, and GRPO. Reinforce is very old. I don't think we're gonna touch that even. It's like arcane. I have not really looked into it, to be honest, either. So the thing is like if you sort of just like take the rollout and you give the reward and you get the reward, and say it's a very long multi-step rollout, right? In the end, the final answer will reward each of the model's tokens in the same way, which means that each token, like it's sort of telling it that, hey, each token that you outputted contributed equally to the final answer. And but the thing is, when you're sort of doing a large agent run, for example, the correct tool call contributed to getting the correct answer much more than say some random text you outputted that during training may just be garbage as well, right? So this is something that's like this is something that's like really important to keep in mind. This is like how you assign credits to like each of the tokens here, and this sort of links again back to like why you need to do SFT before you do RL, because here it sort of teaches the model how to do the good rollouts. And so okay, cool, yeah. So I think here yeah. So you in terms of your RL environment, which is what computes the environment, you probably like end up limiting the number of steps the agent takes depending on the task it has, because say if it's an easy task, you wanted to do it well and you wanted to do it fast. So if it exceeds the number of steps, you can just give it a lesser reward, right? So it's all about how you score the agent in the end. And so this is like where like I've written like the GRPO compute, like I've sort of like helped write the GRPO algorithm here, and I'm just gonna walk through the cool. So the letter counting environment that I was talking about, right? I'll just like walk through this, like this is a big readme that I ended up writing, but this is what the training run actually ended up looking like. I don't know if you can do, yeah. So if you can see here, I did a bunch of evals in parallel. I'll start with this first. So I first made the model like count 3 letters in a word. So instead of like say how many R's in a strawberry, I'd be like how many A's, B's, and C's are in say a big random word, right? And then there is like a difficult version of it where I ask it to count 3 instead of 3, 5 letters, and an even more difficult version where I ask it to count 8 letters. And as I'm increasing the number of letters, I'm increasing the number of letters in the word also. And then at some point, I just like randomly generate a string and ask it to count letters, right? And so this is the eval accuracy. And the thing is, it's interesting to see the performance on it. At least I think it's like interesting to see the performance on it as the model learns. In the sense, if say I am training on difficulty medium, does it get better at difficulty hard? You know, and so I was training it on like the 8-letter difficulty, and so as you can see, as it started here, as it became nicer and like as it immediately became like much better at counting like 8 letters in a word, it also became slightly better from like say like 80 to like 83 percent better at like counting 5 letters in a word. And like these, it's not like the smoothest and like the most correct graph, because again like my training run was just like a mess, but I think it was interesting to see. My training rewards were looking like this. So I had a reward of like, I gave it partial credits for like giving the correct format, and I gave it partial credits, which means partial rewards for each letter it got right. So instead of plain like a binary reward, if it say got 1 out of like 8 letters right, I would give it like, you know, maybe 0.125 as a reward. So aggregate that up. This is like the graph which shows that okay, what was the training reward like average looking like after each 5 steps. So like it started off like at some point at like, you know, it's a little jagged, but in the end like the baseline sort of did improve a little bit.
So when you have a multitask kind of a thing, in this case, counting each letter is given, how does the one single number reward the model that you did this letter right and not that one? So how does that happen?
I mean, so that's something like that's a really good question. And so it's like, how do you even give the rewards, and how do you give like credits, or like how do you give the scores to the rewards? The reward sort of represented how many letters it got right, and again, the thing that wasn't done here was I didn't really like focus too much on the chain of thought and the reasoning part of it. But had that happened, maybe it would have like changed how it was reasoning about like doing the counting. But it wasn't like the reward didn't really signify or represent which letter it got right, but more how many letters it got right. And so the goal sort of became, I need to get the maximum number of correct letters here. Right. The rewards? So I mean here, as I told, it's like I set the rewards myself, right? Like you design your agent's rubrics usually, and so it was like for let's say like a 5 in a 8 letter counting environment. For every letter it got right, I gave it like a partial score. And so if it gave me the correct format, I gave it a partial score. And then like, you know, if it's getting more letters correct along with the correct format, it's getting more and more higher and higher score because it's getting aggregated. Yeah, I hope that explains. Okay, cool. This one? This one? Yeah, it's there's no interpretation except the training run was just like random. Like it was not a good training run, like honestly. There's no other interpretation. I mean, up, loss, down, down, you know. But that usually never happens, and so I see. I'll be honest. I'm also trying to like learn. You know, I've only built agents, but I'm trying to learn some training as well. What I've realized is that you sort of become really good at like understanding. This happened at this step. Let me just check what might have gone wrong, and then you build an intuition where like by looking at a graph you can understand where the problems in the training run was, and so it's just a lot of that.
For whatever reason, can you stop the run at let's say that 40 and then use that as a snapshot?
and use the model as a snapshot.
At that 40 run stop, like now you finished the 60 runs, but you want the snapshot at the 40th run.
You can do checkpointing. And it's
Good enough for me and now.
yeah. So I mean, checkpointing is usually done when you do training, where it's like, you know, after every like epoch or after every step or two, you want to just like ensure that you're saving the weights after that step, because you might want to revert back to that step, and then you might want to restart the training from that step. And this is especially true for larger and larger training runs, because things just break. At least from what I've like started to see, like things just like break as you like scale up the training run. So yeah. So this is this. So my first thing was that my GPU just like would run out of memory, which is like obviously very obvious. So there is a function called wake up, and what this means is that whenever like during training, right, you need to also like run inference on the model, and there's different ways to do it. There's ways where you like have the model sharded over two GPUs, and so you update the gradients on one, it gets replicated on the other, and then you do inference on the other. But I'm doing everything in one GPU. So then let's say a step happens, the weights get updated. Now the VLLM server, which is the inference server, needs to restart and like work on the newer weights. And so there is like a wake up function that happens. But then what happened was that like I didn't really like have a empty cache that I guess you need to have like during that you need to have like during your training run after each sort of like step completes, because and it keeps building up the cache. So what happened was that like after each step the KV cache that like was stored in the GPU memory kept building up, and then it just ran out of memory. The other thing was this is yeah, this was nice, where it's like I had a binary reward where I either like I was talking about like how I in the end like gave partial rewards. Initially I would give it like a binary reward, so either it got the thing correctly or it didn't, right? But then what happened there was, because initially it was not really learning formatting or just like individual things correctly, I would just like say, hey, is the format correct and are all the 8 letters counted correctly? And like the model was just like not doing it well, so all the rewards were 0, and so there was no learning happening. So the fix for this was partially giving it partial credit, but also doing SFT. So after this, when I saw that there was like no learning happening, I sort of went and like did a little bit of a training run happen also, SFT run before all this, right? Then the second thing was, once I added the partial credit, I added it too generously, and then what happened was that I used this thing called distance-based scoring, and so how close the letter count was to the final answer. So it's like if the letter count is like 3 and the final answer is 4, it would like give it a higher score, just be like, okay, you're close enough, you know. But then all the rewards ended up being in a really high range, and because of that high range, again, if all your rewards are like 90% or like 100%, there's no learning happening. And so grad norms, which sort of says how much your gradients are being updated, was like in a very low range. And my eval accuracy was also broken at some point, because I had this thing where it's like sum 1 for r in reward if r is greater than 0. And what this means is that like a wrong answer had a correct format of like 0.1, and every formatted response would like mean it is a correct response, and it would have like true, and so it would like the entire eval accuracy was like 95%. Meaning what I ended up doing was that if the format is correct, I'm just giving a high like.
More related to the design of the reward system.
Yeah, which is actually pretty like important, and like in like most, like this is a really simple environment, right? Like now if you sort of ablate it to your bigger agents, like it becomes an even more difficult problem. To the sense that like, hey, if you're building an agent and if you want a trainable agent, there is a lot of ground to cover there before you even like start touching algorithms, right? So these are like a bunch of things that I end up facing. Um, while I like sort of wrap things up and like and approach like the end of like the slides, I have this collab notebook here that I'd like you guys to sort of visit. If you guys can go to visit, if you guys can go and see this link, alt-glitch/picorl github.com/alt. I hope it's visible. Yeah, sure. We can take a break now and then like maybe you can just like visit this and in the notebooks page just like open up the OpenENV RL204. This is the do you guys find it? Okay, cool. We can take a break. Cool. We can start whenever you guys are ready. So, any thoughts, any questions till now? So, what's basically left is I'm gonna sort of step through and walk through like this RL training run using like a library called Unsloth and using an environment library called OpenENV. So OpenENV sort of just like lets you write these RL environments. So the one that I wrote earlier for the Android one is in like a similar library as this. Essentially, it's just nicer because it lets you get the trace of the agent and like pass it to the trainer. You can sort of use any agent library that you use, AutoGen or like whatever you guys are using. But it's just nicer if you like write it in like a specific format because ENV APIs look nicer and are nicer for training in specific ways. So I think I'll just do this. It's all dark. Okay, so okay, I'll just zoom in. So I've already run this, and I can just like step through this just so that like, hey, I showed you my broken training run, but like, hey, this is what like a nicer, well formatted notebook looks like as well. Unsloth is great. I would totally recommend you to like read and run through their notebooks. They're well documented. They let you train on like free collab GPUs, and it's really slow, but they do so much optimization that like you can still train on like the free low level GPUs that you get from Google using Google Colab, right? And so this just installs the thing. These are just like some pip installs. You can like look at them, but not really like important. This is where you sort of start to initialize the model. So Unsloth is just like a wrapper over like Hugging Face transformers, where you can just like get a model and its tokenizer using the dot from underscore whatever like the function format is. And like here we get like Qwen 3 4B base. This is not an instructable model, which is again not recommended, but these are, oh wait, this is the wrong notebook, never mind. Wait, let me just fix that. Yeah, this is the one I wanted to show you. Okay, cool. Good, we got that. Yeah. Yeah, so here they sort of like get the GPT OSS 20B parameter model loaded in 4 bits so that it's just nicer for GPU and the free GPU that it currently has. And I've sort of gone in like run this. I'll show you the training charts for this as well. They say it here as well, and I think you asked earlier, like why, like should we train over the entire like model weights or should we just train a LoRa? It's always efficient and recommended to train a LoRa. I think now it's sort of like a meta around everywhere. It's like LoRa training is mostly solved. You don't really have any problems with it, right? And you only add like around 1 to actually 20% of extra weights, depending on how big or small the model is. For smaller models, LoRa adds a lot more parameters, but for 20B, it adds around 5% of extra weights. And like with LoRa, what you can also do is just like the LoRa adapter that you train, you can just save it separately and load it in and out whenever you want it, right? These are like the initialization stuff, like you sort of like targeting the modules of the modules of the model to like take the projections from and then give to your LoRa adapter. So these are like sort of like again the meta, like this sort of optimizes everything here. This is where the environment sort of comes into play. They load up the OpenENV process, then load the environment of the right, and they show what the state looks like here. So this game state in the array form, like okay, default play 204, right? So this is the state of the game in the array form. So it's like if you have 204, so you know how you have 204 which looks like this, they just like singularly represented it. And like the legal action is 0 to 3. And so 0 means it moves. It is a upward move when you do an upward move, which is 2048. 1 is like 2 is right and I think 3 is down. And this is what it looks like. You convert the state to a list, as I said, you convert it like a list of things. So the top row is like 0 to 2 and I can also just this is what the starting game state looks like. Right? And once you do legal action, it also shows you what it is. So there is 0 where the legal action, there is action 0, which means moved up. I'm just going to say up. So I'm going to game state looks like so this moved upward and then like this is a response here. So this is like a vertical 204 game. And I don't want to use an LLM to do that. And like the best way to do it here is you can give rewards for like how well the game 204 is going. And I'll explain what the reward mechanism is. RLR or like GRPO is recommended.
But you have to build your own environment and start that for.
It's built already. Yeah. But you can build your own. And I'll point back to the environment designer or something. Essentially this. I think if I yeah, it's a torch face. I think if you go here, sort of see reset, which you want, you'll see set, which is this, and then you'll probably see like code happening somewhere. Yeah, so it is giving you those primitives that environment gets.
This is just taking the primitives, but you build your own. So consider 204 to some environment for evaluation.
Yeah, someone has built it for Wordle as well. And obviously, like, you can check out what these existing environments are, and even like lay them. But you can just like build your own. So this is the Wordle one. Give a message. I think like I have this kind of, but yeah, like this. So again, if you do set, and this is what the agent actually, which is 0. You know, the meaning beta. And it's also good. And then if you 1, it moves it left, and it gives it to the right. It's up, left, up, right, down, left. And then if you do it to 2, it moves it to a down, and then 3 is just left. So you can sort of like have this, you have this like action space, and then you do an hey, output of actions, I show you the state, and then the word is just win the game of 204, right? Rubrics are still left. I think once they introduce it, So again, RA environment setup, what we're talking about. So we kind of like need to, again, it's like the why things that I've already shown you, but they sort of explicitly they sort of like say, let me see if it's like change the, okay. I'll stop reading for a second. Yeah, cool. Yeah, so what they do over here is that so their general strategy is they want to let the agent like bunch of actions to take, and they just have a limit where, hey, just to ensure the agent doesn't write like a lot of actions, it doesn't like sort of kill the process or like just doesn't do anything that's too out of bound. It like terminate the action for 2 seconds, right? So they add a timer for 2 seconds either. And all this does is it takes the action and it executes it in the action ID and then gets the current state and executes this. This execute strategy that they have over here is essentially like while the state is like not completed, this execute actions are there. So if I second time to allow longer study school. Now what like the thing that they do interesting here is they have the agent write Python code to emit the action to like sort of they have the right Python to return the action that it wants it to give, right? What that lets it do is I think they let the agent also look at the code and keep computing it, and it's just like a very big like chunk of Python like script, and so that the agent execute multiple actions at once. Like now there is like a bunch of things here which like reward act is a common agent, and they're doing it because they are having the agent write Python code and they're sort of doing it in this inline thing. They don't want the agent to look at the global module, like look at the dot underscore global, check the reward function, and then maybe like the agent can just go and like tinker there, change the inbuilt Python functions there, just so that it gets a higher reward and it passes. Reward is pretty common, like the agent and go, and so if you just don't get bounds for the agent, you can do this. And because this is like common with code, because the agent can say like, oh okay, I'm just let me action just change the functions so it always have, but always I get a good gradient and stuff, but it didn't really learn that, but it like half is, and so they do this check and modules to ensure that it doesn't really input the code of Python modules. Like we should not allow the execution. Yeah, so what they do, like whatever the Python modules are being imported in this entire like collab, they will let agent access it. And not say like, don't give it global variables, because it could just like look at the global variables and change them and maybe just like how that works. Cool. So now this is the problem, which is like create a new short 208 file using Python code. You're given a list of numbers in the current boot state. Your output like output 0 on what is the optimal your function in this format, and all helper functions will be in like the function that output. Only output that function. So this is like the format on this thing to go. And I think if you sort of prompt the model without RL in this way, it'll be like this is the system and it objects. This is the this is the message that the model always gets, right? And the actual user message that the prompt we wrote is over here. So this is the token format, so what the model actually sees that token, sees that this is a user message, is a message, and so it's like.
So one question is why they asking about the Python code when only at the end of the needs action, right? And it can just be the text of the state and still give an action.
Yeah, it's made in I think it's a free will mostly. And also, I don't really see, I don't see any like deep reason except the fact code is just like a very nice primitive structure models understand. And so the more you can represent reasoning or like just tasks in code, the better models generally form. But in code itself, they like integrate a lot of things. Like Python is just much nicer for models than say the primitive code models, so it's like the primitive format that aspect of it, you know. So this is a function essentially parsing the parsing of the assistant prompt, which is like what the side, and then it's which is did validate output of Python function, did it write effect reward, analyze it, and then does the strategy work, and the strategy gives a positive reward. So this thing works, and then I think they do some for as well.
And when you say strategy, I think you mentioned limiting the number of steps. So I said one strategy. What do you mean by strategy?
Here this strategy is like whatever like it can just be Python code for like outputting, it can just be like 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, you know, just like the strategy. But smart strategy would be like where 8 is, and 8 and 8 are next to each other, 10 to merge them into 16. So just trying to teach you how to think about it essentially. I think over here is where they yeah, so here write a reward function. This is one function, which is does the function work, a valid function. And if it is, then they get a 1, if not, then they get a score -3 or 5. Right? this is a meeting where it checks if model is sort of importing NumPy, or it's importing like some other model that they don't want to use. But it's just like use NumPy to like hack way out of things. So then they analyze it heavily. It's minus 20, which is like a penalization. Right? Then they go study successive, like meaning if the strategy allows the game to terminate, and essentially it's seeing that hey, if it runs strategy under 5 cents and if it gets like a higher number than say 2, 4, 8, 6, 5, 4, 2, right? So then they get a huge direct to say I think they're around 600 because it's essentially the same problem. You were going to write most of things.
Different starting states of the game.
Yeah, so that's what it is. And this is a clean code. These are all the hyperparameters for GRPO. I think the documentation does a good job. Unsort here has Unsort has a very nice documentation on like what the equal meaning primary zero does. So referring to products like to as per your speed, memory requirement, and requires. Right. And then you sort of run this thing I actually did. Yeah, so this is running like around a couple of hours now. I don't know this is happening. Cool. It's brain has died, but I still have the graphs that we can maybe take a look at. Cool. So yeah, this is also the artifact of the training. The field let's read out what the strategies that we look at. Yeah, so self equal 1, evaluate of 4 moves. So it's gonna like move left of D, and then it's like it put an inline function like the right hand function or strategy. Just so the board that it gets is weight. It can like sort of get a state where all the elements are. And it's just like doing some hackery to see that okay, should I move left? Should I move right? Should I move up? Should I move down? Right? And so if here it's like okay, best equal not like my frames. This. So it'll be a bunch of strategies. After 20 steps, you just have to do the strategy thing. And so simply like many possible, let's move down. There is no strategy. Take a possible version even. So the team strategies like be very simple, I guess. So how I think the board game is actually what's playing from. I think here it's doing like more complex code to like check if it moves to select where to move. So as it goes, it's like thought gets better like writing deeper Python code to take it to for it. Here it's move. So what it is look at internal scope for each direction. Like okay, how many merges happen in X or Y direction, right? And say merges are let's say right merge half merge. It will do that. And so it will like sort of do a multi-card search to visit each sort of step from the current board direction. Like the word will be like okay, if I want 2048 over here, if I move how to do this. Or this. Yeah, I think this is now the game. Yeah, so like it's sort of like works through it. Hey, how many merges do I get if I move up? And there's no merge, but if it moves left or right, it won't merge. So then it's probably like wait, the left or right will merge here. Here it's like there's no merge happening here, so I'll do whatever. Here it's like okay, where is the next merge possible? The next possible merge happens only if it moves right and then moves up. So like probably visit and then compute that. So it'll do hyper search, Monte Carlo search. It can do a thing because in the end, like Python code models are trained a lot of Python code. Right? And then you can also like be able to do steps. Right? I think I think what here is being to get a single strategy from which is best optimized for everything. Right? Yeah, exactly that. Yeah, so here it's really heuristic. There's a bunch of different things that depending on like how it's made, it does it. Again, here once it's saying my model was changing that thing, and yeah, there's a bunch of interesting things which is these are the rewards are the object will start with it's like new, but it usually went down first. Like went to like minus 1.37 because maybe it was not doing like moves, it was not with the Python function thing, maybe using direct imports. Then after some point like the reward has to go up. Like an add step 11 is when it takes through at 0 again, and then so it moves at 2.5, 0.7, 0.1, 0.5, and then like it maxes out to 0.8 and like averages up to like say I think 2 in general. So after like 30 steps, and I think there's like 600 runs, and I think 600 steps you'll see this go much more slowly like up and down. This is like the pixel length, which is like certain for the length of the pixel function code, and this is like around averaging around 600 or whatever. But the thing is that around the time that the model was like getting high score of like 2.8 at 24, it was not like the base function ever. It was like getting a more condensed mode, maybe like heuristic based function, and say looking at all the edges. So this is like something we will like extend. And then the length of the Python function will also be increased. I think the magic got us to 2.5. Yeah, it's still learning. Yeah. I think this strategy is the. I'm not sure. This is I think the standard deviation of like the zero for each rollout for each batch of rollouts. So it's like the amount of rollouts I got like a zero. It's sort of acts like how many rollouts just like not really outputting good things. So it must be like when you sorry like getting rollouts and models just like not giving them like giving the answer is like the the learning rate was I think. The learning rate is like how fast you want to learn. I think so. The linear learning. So you set up a learning rate probably want to make sure you're learning it slowly take it as model things. You don't big grading rates. And the number of tokens I think totally out. This is the world standard deviation I think. So I think you can also like running. This is here, and if you go here and click down, you can also just like change these. I think after like 5 minutes, you guys can also see your charts show.
So this is an example of like after a couple of hours, after 2 hours, see how the training is happening. Then they also have like this experiment of see, you like difference from your model and see how it works. And so that's just like one sort of like mind type. Like these guys designed like a root environment and then like did a full like R training.
So just need to like CPU.
Yeah, so just go here and connect to T4 time. So I've used up my example, but like click here and then you'll get an option for like CPU or GPU or whatever, and then just make sure you select T4. I want to go and explore the book. This is when the models learn, when models talk about reason, and reason like any reason for my and like how we can sort of this does some tiny bit like fine tuning as well as create custom method, like how you want the indexes to be, and then for and then like do lots of things. Really, yeah. But instead of thinking is like my book and teach the model to use your way of thinking. You teach the model like say thinking not think but maybe scratch back, but thinking in Python code. So you can definitely do that. I can't because I'm out of like my CPU connection, but I think interesting thing here is first say let you try on your own. Thinking that's so this these are the solutions. I can like scratch back and then like answer. And once you do that, also this prompt and then the chat is like how the responses or the too much order gets changed back, and you can like just convert data set into outputs. They do also the thing that they filter 50 numbers to some extent because they want you want to use the model to understand all format. Again, formatting you want the model to at least know what to output. So then what you do is you just do it, split it up, give it like here because the format is you have to prompt and this is the solution and this is the answer. So then you format and format model and you do exactly that. They do it on 59 rows. So enough for the model to learn. Okay, this is how I should have an answer to it. And they do something like they compute the fine tuning data set like the max sequence length because like max sequence is like maximum output sequence length, and then they don't want the reasoning to be more than half of any models output these like possible output length, you know. So they do that, they tokenize it, convert it, and then they something they do on different examples. So I said I 20 to 70 maybe 200 examples of is like sealing to time model. This is all coming up. The also goes down a little bit and gets to learn how to start at least following it from once it does that, you just like clear your this block to memory cache. I think over here I did have this which is why I was moving. So like, it's nice to see that what things you like from the first principle and you like don't really use any frameworks. Like you come to the same place. But yeah, they like a data set has this and so math problems. Give it to the format and then you know they format it and then they do the function where they calculate the format match correctly, the format match up perfectly, and I think the answer is correct. Like 3 level partial credit for partial one. I think if the answer is correct regardless, they give a bigger score. But again, it's about like some spaces are there which means in correct format. So 3 and then it's like after this close we are chosen if it's within some range. But in a number maybe a rate of 5%. They'll give some power sources. Otherwise it gets quite heavy to mind so much. So they don't give and so they build up this one. And so that's why always like must equal to a classic like from they from the reward and then they calculate times one. When that happens they do some data filtering which is like they own the really long numbers like catastrophic economic set up the GRPO because be able to reward functions. You add your reward function here, you add your here, you train routine and like this big table and all that. So this is another one. I can just go and like do one here and like see the thing and even maybe like download local and do it also. So so yeah, like this is like what application training looks like, which is I said like you evaluate by agents for set that does actually and you get me. So if you say have you want like say what you get to so you do it, you give a person it does the red being 7 steps. The second one it does books for the knowledge. The fourth one it doesn't books but like 4 steps, which is like something for and you want to actually you give it a for your point. And for fourth it is for questions. You give GRPO grouping for how many like what your group is. Calculate your rewards of each like run you reward and grouping. So if it was like one and then you do one like your grouping. And here this will give you like what to reinforce, what has to reinforce and how it should. And that's basically what the GRPO this reinforcement sometimes is like how it sort of changes the language. But what you actually end up getting is these parts, you know. And for the reason GRPO is like because GRPO is like what model is trained on for RL and RL is kind of like as it requires your model to be different formats. Unless like if you require the model to be like the same model to be in different formats, which is a model that will reflect values and the model that will the probability of what it should have. Right? So language model the probability of this model. So every open it will have probability for the next token. So it can have a probability size of like 1,000 or like say 500 12 tokens. Like it have a probability size like some period around 4,000 to 1,000. So for each token it's like high. Let's say the first token you get high, the next token it would be let's equal of what is more probability from this token to that probability. So if you give it high, the next probability tokens the one become hello or like how it goes right. So you have a probabilistic model, but you also want a value version of that probabilistic model. And the value means that you want a that will actually what the model will like give demonstration. And the one is actually instead of your like branches the code that we don't know what like the function. It's actually training your model to get a function. So training your model what they want to be for given. And you train a model, you sort of train a different head on the model. So giving such a value that sort of takes the entire gradient to the model and outputs the number, which is the reward for what the input should look like. Like right now sounds like really weird, but that's sort of speaking. The model is good at predicting what it should say and what should be the reward. Right. So once it's clear the training happens that the model is good at saying that okay, given these probabilities, the reward that I'm with that the reward that the model is going to predict, so the probability the model is going to like output, I'm going to most of that. And so that is the result of the, and so like the actual model say, so say has the probability of say how are you like maybe how this how like 0.8 and 5 or like 0.1 something like that. And the model like predicting like the model breaking ethics is going to be higher because the model weakness. So essentially like you sort of train higher the parameter and through that you get your rewards. And so you don't need to do this, you can get a reward through it, you get a reward from this. That means you have to use the model twice, in the GPU memory is used twice as much. You have to do a lot, you have to make sure that like, the reward align with the reward model will give you very rewards. Because you can just like load your training, you just really have to stabilize. And so you know, just like sort of what to do, you have to like verify it because it's just like that's basically when I'm happy to like communicate with this. And yeah, feel free to check out the code base I sort of clicked on. Just these are my entire training logs as well. These are my things I have like weights and biases things. And I also have like the GPU, PPO and things for it. It's like very commented. So that is just like nice to have. And I don't, yeah, I think it also talks about what the man should look like. So this is say the EAD, this is the exception, function. This is my electron bank. So that I read full critical. This is how I was expecting answer. And this is how I was doing like reset and stuff. So this is like my credit. So I mean, if you like in it a person whatever and I play around next. I'm going to talk about this. I don't think that I actually will discuss things next.
Yeah. One question I have is like, using reading was fine, but like, what do you think means most? Practical purposes, but only on open source. Is that what
yeah, so OpenAI has a long-term hiding API, and Anthropic says that they want to launch a hiding API, and what that let's say for your own custom version of GPT or like what, I'm not sure that you need to have access to the world.
what do like big purpose for
Yeah. You can see
that almost right?
but you can train on this very because that means that the reason why I didn't go for ICD because mostly was posting in India. And that they did a question. In fact, if you keep the key model, so they got the key model through to calling it, and what they did is they had another model that was simulating tools, and it was simulating AI server. So they would like sort of give a tool description to the new model, but it would say description to another fake tool called model, and then they would run the tool model that the new model prompt, they send it as the model, and the model was told bigger as example, and it was told behave as your English was static. And the reason it was because if you want to run the tool first to get it, you can't get like actual Gmail calendar and things like this. Like it's really expensive, like so you're going to get it, might have these stories to learn some your any environment that can happen. So it's really nice thing. Like hey, just like have an LLM, any prompt and be able to say so they like this game that people can start thinking of Bitcoin not SFT, and then what I think after the SFT and then well and then something. Depends on like, what is the like training very frankly finding what very frankly so it's like how much compute will you have in Olivia. Does it make sense for you to do it when you have something to do it? Usually no, but it's such requirements and ideas. Like I like different companies are really like really old with like who has to code. So I think they get told to not really like use cursor even inside because also they will like extract the code base to have it agently what to do, like have it synced, and that's like not allowed. Like so then it's like hey, there is a window DeepSeek which is like really big high-frequency trading things of coding agents because it just makes sense for them to do it, and also they rank very but it's like they're code in OCaml, which is just like models would never be good at time, so like made much be good at time. The effect size is really good for optimization. I think you may not even do like a traffic and like you usually try the lowest hanging fruit first. So for most aspects, like right, from automation, then you go that is train for utilities. If you want the model to be heavy, or I want this generally, I want the model to generally good at many things. Then like I is not efficient for design. So you can really confident in it, which is what happens. But maybe you don't want to exhaust your context. So then you go and you want a lot of different like a that the model is good at. You don't want like deep for all those. So maybe you like do other things. Yes, so you're optimizing generally a competition. Like when like all over the thing towards domain preparation, then what like but if you start a like okay, I model to be good at capabilities. They don't get model to be task using higher level capabilities. Java would probably be better. You say it's like Java is this thing called I can't remember the full form, but it's a way to optimize the prompts and the optimize the prompt system. It's called reflective prompt engine. So it has a model sort of like look at how it's forming, it's a proper kind of prompt. That's what I said. If you just model previous of how to form these prompts, that's course. It was just a data type. Then model is using that to optimize the prompts. So because you do not need deep training if you can.
So practical value add this. So like resources like this to better a lot of tasks and things that level. But working on some stuff and I think is like for our
I think one of the reasons that I think developers are interested, and I'm just talking about the that was developers because they love the apps. Once you understand how the model is training, I said it's a bit more like building environments, but like lab needing interesting environments. And so if you go and say that the model cannot really form this meta task. I have made a task as a different identifiable, which means it's scheduled. That's like very well in general blocking time, like it was a largely model a lot more as well. And like, say you're a JP Morgan financial analyst, like the things you use, and it's a verifiable number, but it's also very deep expertise based. But say you're a developer who also understands what a financial website, you can take an environment and like have models evaluated and get trained on those tasks. And if I did a benchmark that somebody for something which a bunch of languages, for years worth of books, and asked it to work on it and navigate and like fix it. And it's very interesting, like the models, how the model formed. Like obviously they didn't perform really well, but why is that? In fact, you can sort of your like developer does such domain expertise and like take a gym and all go with it. Get better at it.
What developers are working on solutions? They typically use engagement for some topics. But what do you think is the interview of
I don't know phase analysis, like some state group or some state department that's like, hey, we can only use those models in our data and those. But then actually also, but I guess like it's also known that you probably spend a lot more money training a model. People training models are very expensive. Then you need to like have someone to train a model. Then like you need to give them a data, you need to what is used. He goes for it, like if he goes for it, then you need to it's like unless it makes sense for that people. It doesn't make sense for the knowledge.
But in like say for such so like these close nowadays like have something that may be needed for like enterprise use case. So I think that's what I'm gonna set up where you
that's like if you have like like your Claude 4 or whatever, these are big models and like one of the fastest. Then like let's say some of them have use and because the short they don't happen nicely or whatever. You can just like host model really, really fast, which is like a big value add.
what do you say? What is the
Depends. So like say if I like 0.5